Assalamualaikum.
Walaikum Salam, Abdullah. How are you?
I'm fine, sir. Thank you. What
और
about
लेट
you?
कैसे हो गए अब्दुल्ला?
Sir, actually, I was praying.
Okay, no issues here then. No issues. Actually, I was waiting that only 2 to 3 students have joined. That happened to them suddenly. चलो कोई बात नहीं. Let me check और कोई join कर रहा है नहीं कर रहा. Otherwise मैं start कर देता हूँ.
Well, sir, do you have classes after this class?
Yes, dear. I have classes, like 2 classes after this class.
Continuous?
Yes.
Okay.
What
So,
happened?
no. Just can you tell me like when you will be free exact?
Dear, I will be free around 11. It means that it will be around 8:30 according to KSA.
अच्छा 8:30 according to KSA.
ये बताओ क्या बात है
Okay,
सब
sir.
खैरियत?
हाँ सब बढ़िया अल्हम्दुलिल्लाह. Just wanted to talk to you like.
अच्छा.
Okay, I'll DM you at 8:30. Okay.
Okay. No issues.
Okay, sir. Thank you.
चलो चलो ठीक है, हम लोग दोबारा से जरा इसको चेकआउट करते हैं जो हमारा कॉम्बिनेशन ऑफ रेजिस्टर्स था. ठीक है. सो कॉम्बिनेशन ऑफ ओके अब्दुल्ला, अभी आपको याद नहीं दिलाना पड़ा, मैंने कैमरा ऑन कर लिया. ठीक है.
हाँ माशाल्लाह सर, सही है, अच्छी बात है.
ठीक है. हाँ चलो. एक्चुअली यार उस दिन जो है तबीयत ठीक नहीं थी, बहुत ज्यादा टायर्ड था, तो इस वजह से मुझे सही नहीं लगा कैमरा ऑन करना. चलो. सो बेसिकली देखो एवरीबडी. सो अभी इतने बच्चे नहीं आते, अगर ज्वाइन नहीं करते तो आई विल बी स्टार्टिंग. सो सपोज दैट आई हैव स्टार्टेड द क्लास. ओके. सो हम लोगों को कॉम्बिनेशन ऑफ रेजिस्टर्स की कॉन्सेप्ट कर रहे थे. कॉम्बिनेशन ऑफ रेजिस्टर मींस हम लोग we have 2 types of combination. First one is series, second one is parallel. So in the series, combination resistors are joined linearly, consecutively. Just like see this thing, one resistor is there, after ending this at the end of this resistor another resistor is joined in the linear condition, right? Clear? Any doubt? Is this clear everybody?
Yes, sir.
Okay.
Yes, sir.
Yes Abdullah, you are saying something?
No, I said yes, sir.
Okay. So so you can see that thing, only one path is there for the current. Is there any other part apart from this path? If current is this I, is there any other path which is there to flow the current in another with because of another path? The only single path is there for the current, right? So current will flow only this direction, in the straight direction. It will. Yes or no, everybody, at least? Yes or no?
Yes, sir.
Yeah. So basically, in series resistance, the current is same in all the resistors. Clear? Who is there? Let me check. Samina, Shweta. Okay, hello Shweta. How are you? Shweta, are you there?
Yes, sir.
Okay, dear. So, dear, I've just started the class, so don't worry. I'm just revising the parallel and series combination. Okay, just focus on the screen, dear. Okay. So, current has no another path apart from this path. Clear? So, current will flow throughout all the resistance with the same value. The value of current will be same in all the resistance in series combination. Clear? So, current will be same in this as well, and current will be same in this as well. Clear?
Yes, sir.
Very good. But the value of potential difference will be different for each of the resistor in series combination. Clear? Why? Because you know that every appliance have a different rating. Every basically appliance required different voltages to run, because voltage is the main thing which basically helps to flow the current. Yes or no?
Yes,
Water tank example, do you remember?
Yes,
वाटर
sir.
टैंक एग्जांपल, अगर आपका इफ यू हैव वाटर टैंक और आपके हाइट में डिफरेंस है तभी आपका वाटर फ्लो करेगा, अदरवाइज सेम हाइट है देयर विल बी नो फ्लो ऑफ वाटर. क्लियर है?
Yes, sir.
Yes, so same thing happens here. So basically जो हमारे appliances होते हैं, the appliances we have different voltage rating. Every appliance need different voltage. Suppose that right now there is a LED bulb in my room. it requires, I think, 20 volt. I don't know, 20 volt to 20 volt, somewhat like that. So every appliance has different rating. Electric
20
iron
watts.
requires higher voltage. ये सब तो
20 watts, sir. 20 watts.
हाँ 20 watt is the value.
हाँ एक
हाँ
एक्चुअली एक नॉर्मल एलईडी बल्ब या लैम्प एंड ऑल एलईडी का जो रहता है वो नॉर्मली 20 वॉट्स रिक्वायर
20
करता
watt. Basically, I think ये मेरे वाले में I have, I think, 40 watt. 40 watt. It's a larger bulb,
है।
large
हाँ तो
LED.
हाँ तो ज्यादा
So,
बड़ा लाइक ज्यादा ब्राइट भी होगा।
हाँ. So is this clear, everybody? So
यस
that's why when the current will flow through this, potential will be here maximum. Potential will be V here at this point. Suppose that potential is V. When it pass through the R1, potential will be R1 because R1 will draw the amount of potential from the total potential to run. Okay? Whatever is left, what will be left? V minus V1 will be left here when it comes to this point. Because V में से V minus 1 करेंगे, जो whatever is left, remaining तो बचे ना, V minus V1 is what? Remaining value.
यस सर।
So it will go here, and when it will go here, this value, suppose that this value is equals to V2. This value comes out to be your V2. It means that this resistor will use this V2 as to run the to basically to fulfill the requirement. Clear? And you have seen that basically what happens, sometimes happen that when you take the resistors in the series combination, some appliances don't run. Why? Because they don't get the proper amount of voltage to run. Because voltage, basically maximum voltage is used in the starting resistors, and whatever the remaining leftover voltage is there, that is not sufficient to run this basically last appliance. That's why we use parallel circuits in our home. We have different, so basically in our household circuits, you have seen that thing. If you switch off the light, only light will be switched off, not your fan will be switched off, not your AC will be switched off, not your refrigerator will be switched off. But in this case, if you have this word button, if you switch this off, your whole appliances, all appliances will be off. There will be only one button in this case. In series combination, the major disadvantage is that there will be only single button to operate the series combination. Clear?
Yes.
Is that clear what I've spoken so far in the series resistance? Please let me know.
Yes, sir.
Any doubt to anybody?
Sir,
Karishma,
how will be
Samina.
V minus V1 is equal to V2?
डियर अब देखो, आप V तो टोटल है आपका, आपको अगर माइनस, अगर हमारे पास यहाँ कैलकुलेट करना है जो बचा है, वॉट एवर इज लेफ्ट, सो आप V1 आपका यूज हो गया, आपके पास 10 रुपीज थे, 6 रुपीज आपने कैलकुलेट यूज कर स्पेंड कर दिया, तो आप रिमेनिंग कैसे कैलकुलेट करोगे? 10 minus 6.
Yes.
दैट्स व्हाट आई हैव डन, V1 minus V2. जो आपका
So,
रिमेनिंग बचेगा वो 4 ही तो बचेगा ना.
V1 will be more than V, right?
No, V1 will be less than V. V is the greatest. V
Oh,
is greater than V1, and V1 is greater than V1 and V2 as well. V is the maximum potential which is there in the circuit at the starting point.
okay.
Okay. Anybody, any doubt, please let me know. Please don't be like so quiet. This topic is a little bit confusing topic. I don't want that you just take your doubts to your home without asking. Karishma, Samina, and Shweta, what about you, dear?
No doubt, sir.
Clear hai?
Yes, sir.
Chalo, theek hai. Because if you don't speak, I will be assuming that you got my point, and that's not good for you. If you have doubt, please speak boldly. No one is there to stop you. I'm here to answer your questions. So don't be shy while asking the doubts. Clear hai? Okay.
Yes,
So
sir.
next is, so this is what the series combination. So let's talk about the parallel combination. Parallel combination is a different combination in which the joints, suppose that thing, as you have seen this thing, starting point is there. Starting point is there. This is the basically a line. I have a wire, and starting point of this resistance and starting point of this resistance have the same common point of joint.
Yes.
Yes,
So the
sir.
potential gets divided.
And the potential and the end point of this resistance and the end point of R2 as well have the common point of joint.
Yes, sir.
Clear?
Yes.
So basically, when these types, if the resistors are connected end to end, basically if they are connected, like suppose that starting end of the resistor is connected to the starting end of the another resistor, and end point of the another resistor is connected to the end point of the another resistor, so such that combination will be formed as parallel combination. Clear?
Yes, sir.
ठीक है?
Yes, sir.
So now this thing, suppose that आपके पास I1 current है, you have I1 current as total. So now how many paths are there basically for the current to follow? Current has two
Two.
paths.
Two
Yes,
parts.
sir.
Either it, so suppose that I1 is the current which is flowing through the circuit R1, and I2 is the current which is flowing through the R2. Clear?
R2.
So basically the major advantage of this parallel combination is that resistors draw the current according to their needs. Sometimes you have seen that thing, if you give the excess amount of current, your appliance will get short circuit. The appliance will get heat enormously. Sometimes happen ना कि अगर आप करंट इतना ज्यादा दे दोगे वो बेयर नहीं कर पाएगा. करंट रिक्वायरमेंट है 5 एम्पेयर, आप कितना करंट दे रहे हो? 100 एम्पेयर. अब बॉडी को रिक्वायरमेंट है 1 लीटर ऑफ वाटर पर डे. सपोज आप कितना दे रहे हो? 100 लीटर ऑफ वाटर. व्हाट विल हैपन? बर्स्ट हो जाएगी बॉडी. ना
ओवरफ्लो
ओवरफ्लो हो जाएगी बॉडी. सो सीरीज कॉम्बिनेशन में सबसे बड़ा ड्रॉबैक यही है कि इसमें कुछ कैलकुलेटेड अमाउंट नहीं होता. इसमें आप अप्लायंस का कुछ रोल नहीं ज्यादा होता. जितना आप दे देते हो वो फ्लो होता रहता है. बट पैरेलल कॉम्बिनेशन में क्या होता है? पैरेलल कॉम्बिनेशन में
उसी को प्रिवेंट करने के लिए अप्लायंस में फ्यूज लगाया जाता है.
हाँ, तो पैरेलल कॉम्बिनेशन में हम लोगों ने क्या किया? पैरेलल कॉम्बिनेशन में सर्किट जो होता है वो इस तरीके से डिजाइन हो जाता है ऑटोमेटिकली कि जो रेजिस्टर अप्लायंस होता है वो उतना ही करंट ड्रॉ करता है जितनी उसे रिक्वायर्ड होती है. अप्लायंस हैज द करंट, जितना उसे करंट रिक्वायर्ड होता है उतना ही करंट ड्रॉ करता है. तो इसमें सेम अमाउंट ऑफ करंट फ्लो नहीं करता. क्लियर है?
Yes, sir.
अब यहाँ देखो V1, आप यहाँ पे जो वोल्टेज होगा बेसिकली वोल्टेज विल बी V फॉर ऑल द रेजिस्टर्स इन द पैरेलल कॉम्बिनेशन, बिकॉज द जॉइंट पॉइंट बेसिकली यहाँ पे हमारा V, यहाँ पे पॉइंट है हमारा A. ये पोटेंशियल जो कैलकुलेट होगा वो इन दो पॉइंट्स के बीच का होगा. सो पोटेंशियल इन ऑल द रेजिस्टर्स हैव द कॉमन जॉइंट. सो पोटेंशियल तो सेम होगा ना सब रेजिस्टर्स के लिए.
Yes, sir.
Is that
Yes,
clear?
sir.
Shweta
Yes,
and
sir.
Samina, I just wanted to ask. Sometimes I'm using Hindi. If you're comfortable, please let me know. If you're not, please let me know as well. Like I just actually Karishma and Abdullah are the students in my math batch as well. So I won't. Yeah. Okay. Okay, that's great. So is that clear, everybody? The potential difference will be same for all the appliances in the parallel combination. Clear?
Yes, sir.
Very good. So chalo, let's talk. Let me write these things here. And you have different switches for all these resistors in the parallel combination. That's the most important and the best advantage over the series combination is that parallel circuits can be switched on and switched off independently. If you switch off the R1, R2, the current will be R2. Basically, R2 will not be switched off. It will be properly working. Clear? So
Yes,
let me
sir.
write it here. So series combination and parallel combination. So first point between them is current is same. Current will be same throughout the all the resistance, but potential is different. Basically, voltage is different. Clear?
Yes, sir.
Different. Here, one is current is different. Voltage is same. Clear?
Yes, sir.
Any doubt?
No, sir.
Basically, if you have to calculate the equivalent resistance or the you can say resultant resistance. You means you have to see this equivalent, and resultant means that you have to add all the resistors to get the value, the actual value of that combination. Clear? So what you will do is that in series combination, R equivalent will be just nothing but you just have to add the resistance normally, algebraically. R1 plus R2 up to Rn. Clear? But in the parallel resistance, reciprocal will be calculated first. 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. Clear?
Yes, sir.
In the series combination, resistance, the series combination will have maximum resistance. So when you because you can see now, you are directly adding all the resistance, but in the parallel circuits, resistance, the overall resistance decreases. That's why we use, it's better to have higher resistance or lower resistance in the circuit. What is preferred?
High.
Acha, high resistance. Acha, ठीक है.
Sorry, low resistance. Low.
Everybody low resistance, because अगर आपके, if you have the high resistance, so basically you will require a maximum, basically if you have high resistance, so the current will flow very difficultly, that there will be a that flow of current will be very, you can say बहुत ज़्यादा दिक्कत से flow होगा, like high resistance will not allow the current to flow in the circuit smoothly. Clear? So that's why we basically use low amount of resistance in the circuits. Clear? So that's why
Yes,
parallel
sir.
combination is preferred over the series combination. But sometimes we require series combination. So series combination is used. You have seen that thing when you have basically like everyone has attended the wedding. Everybody know, like so when I
Yes,
like
sir.
Wedding, manza, walima, सब कुछ.
so what happened in the wedding is that you have seen that decoration, the decoration used in the basically decoration used in the wedding is connected in the series circuit. If any of the bulb or any of the light gets damaged or gets fused, the whole connection will not be working.
Yes.
Clear? So because we
Yes,
do a
sir.
series combination in the wedding is that because हमारे पास like एरिया बहुत ज्यादा होता है कवर करने के लिए, हम लोग हर एक पॉइंट पे स्विच नहीं लगा सकते. हम लोग एक पॉइंट पे स्विच लगाएंगे, पूरी लाइट्स ऑफ हो जाएंगी, ये ज्यादा बेटर है, या फिर हर पॉइंट पे स्विच लगा के हमें बंद करनी होगी लाइट, ये ज्यादा बेटर है?
Fine.
एक पॉइंट पे तो सीरीज कॉम्बिनेशन वहां पे ज्यादा हमें प्रेफर हुआ, बट जबकि वहां पे लाइट वहां पे बहुत रेजिस्टेंस हाई हो जाता है. तो इस वजह से मैंने मतलब आई अटेंडेड द विलेज वेडिंग एज वेल, बिकॉज सो काफी ज्यादा मैंने अटेंड किया. तो वहां पे इसी टाइप की जब डेकोरेशन होती है ना, तो उसमें क्या होता है, बल्ब कहीं भी एक भी बल्ब फ्यूज हो जाए ना, पूरी लाइट गायब हो जाती है, अंधेरा ही अंधेरा हो जाता है. सो बट ज्यादा बेटर होता है, क्योंकि हम लोग पैरेलल कॉम्बिनेशन उसमें यूज नहीं कर सकते, क्योंकि वो ज्यादा थोड़ा सा वो कॉस्ट इफेक्टिव चला जाता है वहां पे, क्योंकि हमें सारी चीजों को कनेक्शंस को पैरेलल लगाना होगा, दैट टेक्स अ लॉट ऑफ टाइम. सीरीज कॉम्बिनेशन में क्या, एक तार ज्वाइन किया, पूरा उसमें बल्ब के सॉकेट्स लगा दिए एंड ऑल डन. इट टेक्स ओनली हाफ एन आवर और 1 hour, बट पैरेलल कॉम्बिनेशन विल टेक मोर देन 3 to 5 hours. सो इज दैट ठीक है. सो यहाँ पे आई विल ओवरऑल रेजिस्टेंस increases and overall resistance here decreases. Clear है?
Yes, sir.
So in the last assessment, how many of you got the results? What were the results of yours? Assessment होता है ना last, resistance and resistivity का. What was the result of that assessment? Abdullah, Karishma, Samina and Ashweta. How many of you got the what was your scores?
So it's out of 5 marks, right?
Yeah, it's basically there were 5 questions. So how many of you got the correct answer?
So I couldn't do the after class assessment. It's not
Okay.
coming from here.
So Ashweta, like you were not able to like basically attempt that assessment.
Yes, sir.
Okay. Samina, how many of you how many answer you got the correct?
So 4.
4. What about Karishma and Abdullah?
सर याद नहीं है, शायद से 3 थे, पक्का नहीं पता.
चलो, अब्दुल्ला आपके कितने?
क्या क्या?
असेसमेंट हुआ था ना लास्ट क्लास में, रेजिस्टेंस एंड रेजिस्टिविटी का, और ऐप पर जो होता है आपका, जैसे मैथ्स में होता है।
हाँ शायद।
शायद नहीं, हुआ था। आई नो दैट थिंग। कितना,
अच्छा,
कितने स्कोर किया आपने?
आई डोंट रिमेम्बर, शायद 33।
30, यानी एक ही आंसर करेक्ट किया बस।
2 शायद।
दैट्स नॉट अ गुड थिंग यार, दैट्स
सर
नॉट
मैं
एक्सपेक्टेड।
आपको सर मैंने आपको शायद बताया होगा कि मैंने 8th ग्रेड से लेके अभी तक मैंने फिजिक्स की नोटबुक को हाथ खोल के भी नहीं देखे, तो आप क्या ही एक्सपेक्ट करेंगे?
डियर कब करोगे फिर आप खोल के, कब देखोगे अगर आप अब नहीं देखोगे तो?
ये
बताओ आप
श्योर है
मुझे।
सर। सर बस अभी तक तो चल भी जाएगा, लेकिन मुझे 11th की टेंशन है। अगर मैं पीसीएम कुछ लूंगा तो फिर तो
अब भी नहीं चलेगा डियर, अब भी नहीं चलेगा। अगर आप नहीं पढ़ोगे तो अब भी नहीं चलेगा, सच में बता रहा हूँ। अगर
नहीं
आप
सर,
11th की
साइंस में तब भी
फिजिक्स,
पास हो जाऊंगा।
फिजिक्स तो आप 11th की छोड़ ही दो आप, क्योंकि फिजिक्स 11th की
तो वही तो
बहुत।
कह रहा ना, उसी का तो
आप
टेंशन है।
10th क्लास से जाके जब आप 11th में जाते हो ना, फिजिक्स लेते हो आप, जो 10th की फिजिक्स होती है आपकी, कुछ भी नहीं है। आपके 4 चैप्टर है फिजिक्स में, आपकी इसमें हालत खराब हो रही है। 10th में दो, 11th में 2 बुक्स हैं, और
जी
दोनों
जी,
और
मान।
दोनों बुक्स में कुछ भी ऐसा कॉन्सेप्ट नहीं है जो आप नए पढ़ के, वो पुराना पढ़ के जाओगे। सब नया होगा, एवरीथिंग विल बी न्यू। सिर्फ एक कॉन्सेप्ट को छोड़ के, जो आप मोशन स्पीड लाइट होगा, मोशन स्पीड होगा। उसमें भी आपने सिर्फ इंट्रोडक्शन पढ़ा है भी, जो 9th क्लास में पढ़ा है। जो मेन मोशन आने वाला है वो 11th क्लास में है, और वो भी 1D के साथ 2D, फोर्स, लॉज ऑफ मोशन, वर्क, पावर, रोटेशनल। जब तक आप
फिर
रोटेशनल
वो
में पहुंचोगे,
मोशन को
जब तक
पढ़ते
आप,
पढ़ते लूज मोशन हो जाएगा।
तो इसलिए इसको लाइट नहीं लानो आप लोग। आप देखो, दोज हु आर गोइंग टू टेक द साइंस इन द 11th क्लास, आई एम नॉट बेसिकली लाइक डिमोटिवेटिंग यू, बट दैट्स अ फैक्ट। इफ यू डोंट
सर आप इतना
लाइक,
कैसे पढ़ लेते थे यार?
यार पढ़ना पड़ता है, सबका
नहीं
रिजल्ट
मतलब अभी
डाउन।
पढ़ कैसे लेते हैं आप?
चलो अभी अभी पहले ये करते हैं, वो बात की बात है, अभी बताएंगे
अच्छा सर,
उसको।
बस एक चीज
हम्म।
मुझे ये बताइए, आपको 12th के बोर्ड्स में कितने आए थे?
किस चीज में?
ओवरऑल ओवरऑल फुल सारे
90,
सब्जेक्ट्स में,
95
आउट ऑफ 100?
आउट ऑफ। बेसिकली आप परसेंटेज पूछ रहे हो या फिजिक्स के मार्क्स पूछ रहे हो?
नहीं नहीं, परसेंटेज।
परसेंटेज
खाली फिजिक्स का नहीं, सारे सब्जेक्ट मिला के टोटल।
95, 95 थे।
माशाल्लाह।
अभी आप उसको छोड़ो, मेरी छोड़ो, अपनी देखो अभी, ठीक है। मेरा तो हो गया पास आउट। अभी आप अभी 10th क्लास में, अभी 11th में भी जाओगे, 12th में भी जाओगे। So is that clear everybody? Overall resistance increases in the series combination and overall resistance decreases in the parallel combination. Clear?
Yes, sir.
चलो ठीक है। So let's do some numerical based on that thing. Here's the question here. Here's the question. So let me take this question. Those who are not preparing for boards right now, like they are just wasting the times. Nothing will be happened here if you won't prepare and start practicing. आप जब तक प्रैक्टिस स्टार्ट नहीं करोगे तो आपको रिवीजन का टाइम, आप रिवीजन कहाँ से करोगे जब आपको कॉन्सेप्ट ही नहीं पता होगा? कॉन्सेप्ट नहीं पता होगा, डाउट्स कहाँ से आएंगे? और डाउट्स नहीं होंगे तो फिर आप क्या ही प्रोग्रेस करोगे आप? क्लियर है? सो स्टार्ट तो करना पड़ेगा, एक स्टार्ट तो करना पड़ेगा। विदाउट स्टार्टिंग, आप लोग, अगर आप स्टार्ट ब्लॉक पे खड़े हो रेस के, और आप कहते हो कि मुझे रेस जीतनी है, तो रेस में आपको एटलीस्ट आपको भागना तो पड़ेगा ना। देन यू विल बी एबल टू कैलकुलेट, प्रिडिक्ट दैट यू विल बी विनिंग और नॉट। अच्छा ठीक है, बनते हैं। अच्छा, हाँ हाँ, बच्चे हो जाएंगे। अब तो नहीं, ये सब गॉट इट डियर, गॉट इट, आई नो, बट चलो अभी आप वो चीज छोड़ो। जितने बच्चे पास होंगे वो होंगे, अभी इसके पे फोकस करो आप। देखो ठीक है। सो तो ओके एवरीबडी, सो यार ये चीज तो चलो ठीक है। अच्छा, एक वन मोर थिंग, हाउ मेनी लाइक डेरिवेशन कितने लोगों के स्कूल में हुई है सीरीज कॉम्बिनेशन और पैरेलल कॉम्बिनेशन के लिए इक्विवेलेंट रेजिस्टेंस की?
सर ये
लैब
है सिलेबस में?
प्रैक्टिकल्स।
सर
आई
है
एम जस्ट
क्या ये?
आस्किंग, आई एम जस्ट आस्किंग, क्योंकि देखो कुछ स्कूल्स फॉलो करते हैं अपने डेरिवेशन खुद से करा देते हैं, क्योंकि
नहीं है सर,
श्वेता आपके में हुई है, ठीक है, श्वेता के में हुई है।
मेरे में हुई है तो पता नहीं सर, हुई होगी
अच्छा
तो
ठीक है,
देखना
समीना,
पड़ेगा।
समीना,
No, I didn't understand your question.
I'm saying that is there any derivation done in your school related to combination, series combination, equivalent resistance
The derivation in the terms are you like saying
in
lab
terms of
practical?
V and I, in terms of V and I?
Yes, sir.
अच्छा ठीक है, चलो फिर ठीक है, इस क्वेश्चन से पहले हम लोग डेरिवेशन ही देख लेते हैं, बिकॉज डेरिवेशन देखो ज्यादा बड़ी नहीं है, छोटी सी डेरिवेशन, डोंट वरी, इट विल टेक ओनली हार्डली 2 minutes. इस क्वेश्चन को बाद में कर लेंगे, पहले डेरिवेशन देखते हैं. तो तो डेरिवेशन आपकी इस तरीके से सिंपल सी. So resultant resistance. Let me take picture. मैं पिक्चर ले लेता हूँ इसकी स्नैप. बेसिकली पिक्चर इन द सेंस वो जो सर्किट डायग्राम है उसको बनाने में बहुत टाइम लगेगा, बट स्ट्रेट फॉरवर्ड डायग्राम है, कुछ नहीं. Here it is. So basically these are the three resistance which are connected. So these are the three resistance which are connected in series. Clear? So basically how you will calculate the equivalent resistance. So suppose that thing. So see that thing. I've told you that the current will be same throughout all the resistance, but the potential difference will be different. Clear? Yes or no?
sir.
So basically, so can I say, so if I calculate, so I can write this as V1, V is as V1 plus V2 plus V3. Why? Why? Because if you add all
क्योंकि
the
वो
potential
सीरीज में है।
difference, yes, देखो potential difference, when you will add all the potential difference in the resist of the of R1, R2 and R3, you will get the whole potential. You will get the whole value of the potential, right? Yeah. So when you apply the Ohm's law in each of the resistance, clear? In each of the resistance, you will get the so your current, basically the current flowing through the whole circuit. So current flowing through the whole circuit will be same as I. Yes or no?
Yes, sir.
So basically, so a resistance will be, if you see this thing, resistance will be equals to V by I, total potential, total voltage by total current. So this R is the actual, this R is the total resistance, R equivalent. This R is the total resistance of the circuit. If you are dividing the total potential by current, total current, you will get the R. That R will be the whole resistance of the circuit. It means that when you add R1, R2 and R3, you will get R. Clear?
Yes, sir.
So let me take this thing as, yes, Abdullah?
No, I said yes.
Okay. So I'm writing is, since the current is same in all the resistance, current, since the same current is flowing through the current I flows through all the resistance. Resistance R1, R2 and R3 in series. So on applying Ohm's law, Ohm's law to each resistance. So what you will get is that V1 potential is different, current is same, R1 is the R1 is the resistor one. Secondly, V2 is equals to I1, sorry, I current will be same, R2 will be different. Clear? Ohm's law, we are applying Ohm's law separately on each resistance. Clear? Is this
Yes,
clear
sir.
to everybody? Yes
Yes,
or
sir.
no? Please let me know. Sure?
Yes, sir.
Yes, sir.
And V2 is there, V3 will be same, R3, this is 2, this is 3. Clear?
Yes, sir.
Yes, sir.
So adding all the equations. If you add all the equations, you will get on the right hand side the total amount of voltage V1 plus V2 plus V3 is what? Total amount of voltage in the circuit.
Yes, sir.
Adding all the equations, you will get V1, V2, V3 is equals to IR1, IR2 plus IR3. Clear?
Yes,
I
sir.
is there. So just a second. So if you take this thing, so can I write V1 plus V2 as V, and if I take I as common, R1 plus R2 plus R3 will be left, yes or no?
Yes, sir.
And can I write V as, V is the total amount of voltage, can I write V as I total current into total resistance, which is R equivalent, is equals to I R1 plus R2 plus R3. Yes or no? Is this step clear to everybody? Yes or no? Please let me know.
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
Sure?
Yes.
Okay. So this I will cancel out this I, total current will cancel total current. So what will be left is that R equivalent is equals to R1 plus R2 plus R3. Clear? Clear? Eh?
Yes, sir.
Any doubt?
No, sir.
Sure? Okay. So that's how you will. So this is only for 3 resistors. So you can take it like it can be calculated for n resistors, Rn up to Rn. Clear? Please let me know if it's clear to you or not.
Yes, sir.
What about Samina and Shweta? They are not responding.
Yes, sir. Clear.
Yes, sir.
ठीक है, तो चलो अब क्वेश्चन कर लेते हैं. So this is the question. The question is saying that 6 ohm resistance is connected in series with another 4 ohm resistance and a total potential difference applied is 20 volt across the combination. Calculate the current through the circuit and the potential difference across the 6 ohm resistance. So calculate this one first. Just a second, actually my computer laptop would hang. Let me share my screen to you again. Okay. So solution is there. So basically R1 is 6 ohm, R2 is 4 ohm. V is equals to 20 volt. Clear? That's what this So if you need to calculate the equivalent resistance, how you will calculate the equivalent resistance in series circuit? Directly add them up.
R1 plus R2, R plus R3, whatever.
Yes, very good. So R equivalent will be equals to 6 plus 4 is equals to 10 ohm. This is the, so you can see that thing. 10 ohm, the resistance is overall resistance increases. Clear? Yes or no?
Yes, sir.
Yeah.
Yes, sir.
So if you need to calculate the I, total current I, you have to take the total voltage divided by total resistance, which is
Yes, sir.
equals to 20 by 10. So 2 ampere of current is there in the circuit. Clear? And if now tell me, if you, the question is asking calculate the potential difference across 6 ohm. So it's a series circuit, so current will be same, but the potential will be different. So what you will
Different.
do is that if you need to calculate the potential difference across this, V1 is equals to I, current will be same, and R1. Clear? So V1 is equals to I is 20, oh sorry, 2, R1 is 6, which is 12 volts. So 12 volt has been used by this R1 resistance to operate. Clear? And the remaining 8 volt is used by the 4 ohm circuit, 4 ohm resistor. Clear? Hai? Is that clear or not?
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
Sure?
Yes, sir.
Check it. So एक और question है. Just give me a second. तो क्वेश्चन अभी बेसिकली इनके इंडिविजुअली इतने खास नहीं है. चलो पहले रजिस्टर पैरेलल का और कर लेते हैं, फिर उसके बाद कंबाइन क्वेश्चंस करेंगे. कंबाइन क्वेश्चन ज्यादा हैं इसमें, बस इंडिविजुअल क्वेश्चन स्ट्रेट फॉरवर्ड है. बट जब कंबाइन क्वेश्चन आते हैं जो सीबीएसई में पूछे जाते हैं, दैट द क्वेश्चन दैट हैज बीन आस्क्ड इन सीबीएसई इज बेसिकली बेस्ड ऑन कॉम्बिनेशन ऑफ सीरीज एंड पैरेलल. बोथ कॉम्बिनेशंस आर देयर इन अ सिंगल सर्किट. देन यू हैव टू सॉल्व इट. First do the combination, basically the derivation of parallel circuit, and then we'll be doing the combination. So question is, so basically resultant of resistance in parallel combination. Clear? So let me take again the pic of this diagram. Yeah. This question. So in this question, देखो, total resistance is R1. Basically, the equivalent resistance will be equals to the addition of R1 and R2. Current will be different. That's why I1 and I2 word is used. Potential will be same for everything, for all the resistors. Clear? Potential will be same, na?
Yes, sir.
Clear? So, so basically, total current. So total current is equals to I is equals to I1 plus I2. Clear? I1 and I2.
Yes, sir.
Yeah. The resultant, suppose that the resultant resistance of parallel combination is R equivalent. Okay, R equivalent word is used, and we are applying the Ohm's law. Then apply Ohm's law to each Okay, so apply first we have apply the whole resistance and apply the Ohm's law to hold up circuit. Clear. So this will be equals to, so V will be equals to I total current into total resistance, yes or no? And your I will be equals to V by R equivalent, yes or no, everybody?
Yes, sir.
Yes or no? Clear. And you can see that thing, since the potential difference is same across all the resistors and the current is different, so I can use the Ohm's law, yes or no?
Yes, sir.
Clear?
Yes.
Yeah. So basically, since the resistance R1 and R2 are same in parallel, is the same, and applying the Ohm's law individually, to each separately. So first will be equals to I1 will be equals to V R1, yes or no?
Yes, sir.
This is your equation number 1. I2 will be equals to V by R2, yes or no? This is your equation number 2, yes or no? Please let me know, is this clear or not?
Yes, so clear.
Yes.
Very good. So when you add all the equations, adding equation 1 and equation 2, you will get I1 plus I2 is equals to V by R1 by V by R2. Okay, V by R2. So I1 plus I2 is what? Total current. Here, yes or no? Is equals
Yes,
to,
Yes, sir.
if you take V as common, you will get V is equals to V R1 plus 1 by R1 plus 1 by R2. Clear? Hai?
Yes, sir.
So I can be written as V by R equivalent, because total potential divided by total resistance will be equals to total current. I is total current, na? So I can be written as V by R equivalent is equals to V. Is this step clear to everybody, yes or no?
Yes, sir.
So this V will cancel out this V. Clear? So what will be left is that 1 by R equivalent 1 by R1 plus 1 by R2. Clear? Hai?
Yes, sir.
So that's how the resistance of the parallels combination is achieved. Clear? Kashma, Samina, Abdullah, and Shweta.
Yes,
Please let me
sir.
know, is this clear or not?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Very good. So let's do one question based on this concept. So this is the question. Circuit I'm writing, basically I'm just pasting picture of circuit. So wasted this. So solution will be, so R1 is 3 ohm and R2 is 6 ohm. You can see that thing, starting point is connected with starting points. Suppose that this is the starting point of this resistance and this is the starting point. So both the resistance are connected end to end, and this is the end point and this is the end point. Clear? Or you can just have the common point of common joint as well here. If you don't mark this here, you will get the common joint at this junction, this point. Clear? Yes or
Yes.
no? Clear? Very good.
Yes, sir.
Yeah. So R1 is equals to 3 ohm, R2 is equals to 6 ohms. So R2 and R3 are this. So if you have to calculate and the so if you have to calculate the R equivalent, so you will take the reciprocal. So R equivalent will be equals to R1 plus 1 by R2. Clear? So 1 by R equivalent is equals to 1 by 3 plus 1 by 6. So 1 by R equivalent is equals to, so you just don't don't take LCM in this question, in these types of question, in the parallel combination, don't take the LCMs, just cross multiply them. So if you cross multiply them, this will go multiply with this and this will multiply with this, and the denominator will be multiplied to each other. Clear? 3 into 6 and 6 into 1 will be 6 plus 3 into 1 will be 3. So 9 by 3 into 6. So 3 3s are 9 and 3 2s are 6. Clear? So R equivalent, if you 1 by R equivalent is equals to 1 by 2. So if you reciprocate this thing, you will get R equivalent as 2 ohms. So now tell me, overall resistance decreases or increases? If you take this circuit, if you take this like resistors in the series combination, what will be the equivalent resistance? Everybody? It's an open question. I'm not asking to specifically anybody. I'm asking that if you take these resistance in the series circuits, what will be the amount of resistance?
6 plus 3, 9.
6 plus 3, 9. Only Shweta has answered this question. That's a basic one. Like, okay. Now see this thing, compare this. If you take the resistance in the series, you will get the 9. But if you take this resistance in the combination of parallel combination, what basically you are getting? You are getting 2. So the overall combination has been decreased in the parallel combination. So that's why it's better to take the parallel combination of resistance when we have to be very basically electricity efficient. Clear? Because the overall resistance decreases and current is easily allowed to flow in the circuits. Clear है?
Yes, sir.
चलो ठीक. Just give me a second. So let me take one question here. अगर क्वेश्चन कुछ ठीक है, because ज्यादातर कॉम्बिनेशन के ही क्वेश्चंस हैं ढंग के, इंडिविजुअल क्वेश्चंस बहुत कम है. चलो ठीक है, मिल गया. In the circuits, current is flowing through the 5 ohm resistor is 1 ampere. So basically this current will be different or same in all the resistors? Everybody?
The current will be different.
Obviously current will be different. So So this current is given, basically 5 ohm resistance current is given, which is basically I1, which is equals to 1 ampere. Clear hai? We need to find the current across through other all resistance, which is I2, and this is I3. Clear hai? Yes or no?
Yes, sir.
Very good. And is there any given potential difference given here? I don't think. Let me check the question again. Specifically, no question is given. Yeah. So basically, the amount of basically, so if you need to calculate, so potential difference will be the same for all the resistors. Potential is not given, na? But the current is given. So potential will be same for all the resistance. I1 will be equals to, if it need to, I1 is basically given as 1 ampere. I2 we need to find, I3 we need to find. So basically, if you have to calculate the total amount of potential difference in this circuit, you will be writing I1 as V by R1. Yes or no?
Yes, sir.
Yes, sir.
I1 can be written as V by R1, applying Ohm's law, nothing but Ohm's law.
Yes, sir.
Yes. So I1 is already given, which is 1, is equals to V is not given. R1 is given as 5 ohm. So V will be equals to 5 volt. Clear? R1 is here 5 ohm. R2 is equals to 4 ohm. R3 is equals to 10 ohm. Okay. So we have calculated the potential difference. Clear? Now we need to calculate the current through other resistance as well. Okay. So I2 will be equals to V by R2.
Oh, yes,
So
sir.
I2 will be equals to V is
V
given, which
by
is 5, 4.
Yes, sir.
So it comes out to be 1.25, sorry, ampere. Clear? Similarly, I3 will be equals to V by R3. So I3 will be equals to V is 5,
5
R3
by
is
10.
10, which is comes
1
out
by
to be
2.
0.5 ampere. Clear?
Yes, sir.
So that's what the question is. Is there any doubt? Please let me know.
Clear, sir.
Sure?
Yes, sir.
Okay, chalo. So we have done the parallel combination and the series combination in class itself. Only the basically the numerical which is left there is the combination of series and parallel. So in the next class, inshallah, we'll be doing this thing, and only think 2 classes are required for this chapter still, because this is like I don't want to skip anything. So that's why I'm taking a little bit extra time. So because this chapter and the light chapter, the two most important and the most weighted chapter of this class, because it contains like the maximum amount of numericals in the whole syllabus of physics. Because magnetic effects has no numerical, human eye has no numerical, only I think like बहुत basics से numerical है human eye में. So इसलिए these वो chapter जो है वो I think hardly 2 classes में complete हो जाए, hardly 2.5 classes, both the chapters. But these chapter requires at least 5 to 6 classes, and I think we have covered 4 classes. I think 4 classes हो गई हमारी, 4th class थी नहीं? I
इस
think so.
चैप्टर की
इस chapter की I think 3rd है या 4th है ये class?
सर 3rd है शायद से.
3rd है ना? So 5 classes मैंने बताया 5 to 6 classes minimum required है. ठीक है? So अब देखो जल्दबाजी में syllabus cover हो जाएगा, but क्वेश्चन ऐसा आ गया कोई सा आपके एग्जाम में जिसकी वजह से आप वो अटेम्प्ट ना कर पाए, so that's not a good thing. So please be patient. And करिश्मा, I will take that topic जो आपका वो commercial unit वाला था ना, वही वाला I think portion आपको समझ नहीं आ रहा ना?
सर मैं आपको कल ही बताऊंगी क्योंकि मुझे नहीं पता सर.
अच्छा ठीक है, कोई बात नहीं, मैं कल देखता हूँ, जैसे मेरे को स्लॉट फ्री होगा वो आपको इन्फॉर्म कर देंगे. मैं भी इन्फॉर्म कर देता हूँ, व्हेनेवर आई गेट स्लॉट फ्री तो वो आपको वहां पे मैसेज कर देंगे, यू विल ज्वाइन. ठीक है?
ठीक है सर.
ठीक है. So that's all everybody, and thank you so much for joining me, and please revise. अभी तो क्वेश्चंस नहीं होंगे इस पे बेस्ड, बेसिकली आप तो अभी आप सिर्फ कॉन्सेप्ट रिवाइज करो और डेरिवेशन पे। सो जो हम नेक्स्ट क्लास करेंगे ना, उसमें जो न्यूमेरिकल्स आएंगे वो ज्यादा इंपॉर्टेंट न्यूमेरिकल्स है, क्योंकि इस पे सिंगल बेस्ड न्यूमेरिकल्स बहुत कम होते हैं, पैरेलल पे सिंपली बेस्ड न्यूमेरिकल्स बहुत कम है, और सीरीज पे। बट कॉम्बिनेशन पे जो बेस्ड है वो न्यूमेरिकल ज्यादा अच्छे हैं। तो हम लोग उसको नेक्स्ट क्लास में करेंगे। अभी अब टाइम हो गया 8:32 हो गया अराउंड। सो ओके, सो दैट्स ऑल फॉर दिस क्लास एवरीबॉडी। इंशाल्लाह नेक्स्ट क्लास में विल बी डूइंग दैट।
असेसमेंट।
सर
नो नो असेसमेंट नहीं है अभी, नहीं,
सर
नेक्स्ट क्लास में होगा। हाँ करिश्मा।
मुझे एक डाउट है, जो आपने v इक्वल्स टू 5 b लिखा है वो a होना चाहिए या v होना चाहिए?
कौन सा बचे?
सर इसी में जो आपने v इक्वल्स टू 5 b लिखा है, जिसमें
v
फर्स्ट
इक्वल्स टू
में 5
5।
लिखा है,
डियर वोल्टेज की क्या होती है एसआई यूनिट?
वो तो v होती है ना?
हाँ।
अच्छा ठीक है, वही तो मुझे, हाँ।
अच्छा v बेसिकली वोल्टेज, मैंने पूरा नहीं लिखा, देखो v वोल्टेज को हम लोग स्मॉल डिनोट करते हैं,
हाँ
वोल्टेज वो
सर
है।
पता है पता है।
ठीक है, ये डाउट था,
वोल्टेज इज इक्वल टू 5 वोल्ट।
ये डाउट था करिश्मा।
सॉरी, वी इज इक्वल टू 5 वोल्ट।
नहीं, मेरे को कंफर्म करना था बस, वो था।
हाँ यही होता, वो कोई बात नहीं, वो हो जाती है कंफ्यूजन, कोई मसला नहीं। अब ना एनी डाउट अपार्ट फ्रॉम दिस?